Hi guys, let's do this question product of array except self. So you can read the problem statement, but basically it says that this is an array, a list of numbers, and we have to give the output such that for every index here, it should be a multiplication of the entire array but itself. So for the first one, we'll leave 1 and multiply everything 2 cross 3 cross 4, that's 24. For the second element, it's just going to leave this one out, so 1 cross 3 cross 4 is 12 and so on and so forth. Now, it does say that we need to have an O of n algorithm here, and we cannot use the division operation. So why cannot we use the division operation? Because if we could use the division operation, then what we could have done is we could have just done a one pass and multiplied everything. So 1 cross 2 cross 3 cross 4, that would be 24. And then we could have divided 24 by 1. So we could have put 24 here. 24 divided by 2 would be 12 and so on and so forth. So that would be a one pass solution, but that's not what they want. Or what could be another solution? Another solution could be if we just if we are going if we want the corresponding output related to 1, we could multiply everything here. So 2 cross 3 cross 4, that would be 6 cross 4, 24. Then we come to 2, and for that we again do this calculation. So that would imply that we are doing n minus 1 calculations, which is of the order n for n elements. So that's an n square solution, two for loops basically. So that's not permissible because it states here that we need an O of n solution. If you scroll further down, it says follow up. Can you solve the problem in O of 1 space complexity? So basically they are saying we cannot, in an ideal world, we should not even be using memory. Now this is a follow up. So I guess there are two parts to it. One is easy and one is hard. So for the easy solution, we can use memory as long as it runs an O of n time solution. But in the hard variant of this problem, it's required that the run complexity should be of O of n, but the memory complexity should be O of 1. So if we think about it, basically this can be resolved, can be solved by multiplying anything that comes before the said element. So if we want to put the number corresponding to 3, what we have to do is we have to multiply everything that comes before 3, and we have to multiply everything that comes after 3. And if we do that, then this is what we need to put in here. So instead of continuously multiplying every time we iterate from, let's say, from 3 to 4, instead of multiplying each number again and again in the entire series, what we can do is we can keep a running track of the multiplication product. So here we'll have 1, then we'll have 2, and then the next time we do it, we will not have to multiply 1 cross 2 again to multiply it by 3. We already know the product until here was 2, so we just multiply this by this, and that would yield 6. But that would be such that the complexity is O of 1 for this multiplication, because all that we did is we added this number after the product here, and so on. So we can basically have a prefix product and we can have a postfix product, and then we can combine the two is what we can do. So let's just shoot for the stars here, meaning that we can do the calculation in one go, keep all the calculation in a result array rather than have two individual prefix and postfix arrays, which would be O of n in memory complexity. Um, so what we can do is we can do a resultant array, and this would be 1 cross length of nums. So this is just the initial state. The resultant product has of course to be equal to the length of the individual of the input array, and we'll do the prefix calculation. So let's say prefix is equal to 1, and for I in range of length of nums. s- And what are we doing? We are saying resultant array. So this is essentially the prefix array is will be so the first one will be equal to the prefix, which is 1, and then the prefix itself would be prefix, which was 1 multiplied by nums of I. So what is going on here? Basically, we have to be one index ahead, right? So here we'll say prefix is 1, that's fine, and then The resultant is 1. The prefix was 1 to begin with, but then the prefix would be calculated, which would be 1 cross 1. So that's 1 again. We move to the next stop, which is the second one. So here we'll say the result should be equal to the prefix. So the prefix was 1. Let's just build it while we talk about it here. So the first one was 1. The second was 1 again. Why? Because the prefix was still 1. So resultant result was the same as prefix, which was 1, and then the prefix would be prefix multiplied by nums. So in this case, now prefix would be 2. So okay, now prefix is 2, so we get the result as 2, and now the prefix would be 2 cross 3, so the prefix would be 6, and in the next iteration, we'll put in 6 because prefix is 6. So this is the resultant array. This is the prefix array. Now we have to, of course, have the postfix. So let's say postfix is equal to 1. And now this for this turn we have to start from the back. So it would be an inverse iteration. So we'll say for I in range, and how do we do that? We'll say length of nums minus 1 because the index is 1 before the length, and we'll go until minus 1, which is non-inclusive. So we go until 0 basically, and the decrementer is minus 1. And here we cannot just say the result I, we cannot just say this is equals to postfix. And why can't we just say that? Because otherwise what would have happened is this 6 that we have here, this would get overwritten by 1, so we cannot do that. So here we'll say the result is multiplied by the postfix, and the postfix itself, how would we get the postfix for the next iteration? Because what is the use of this postfix? The reason why we need this postfix is so that we can, once we iterate to the second last position, we can use that postfix. So this would be whatever it was multiplied by nums of I. So 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 when we go on to the second spot, we would have multiplied whatever was uh, nums of I, which was 4 in this case. So nums of I was 4, and then we have to multiply it by this. And why do we have to multiply it by 2 here? Because 2 is basically the sum product of everything before it. So what we are doing is we are multiplying everything before this element 2 here, and then we are multiplying everything after. So after was 4 here. So similarly, we can do a visual here. So it started with a 6 initially, because in the first instance, uh, the postfix was 1, but the result carried on from the previous one. Now the postfix became here 4 because it got multiplied with the last integer. So the postfix became 4, and then it went on here. So 2, it's picking 2 from the resultant array. So it's there's a lot going on here. It doesn't seem like there's a lot going on here, or maybe there's not, but what essentially is going on here is we are using the resultant array as the current prefix one. So we will pick this value from here, and we'll pick the 4 value from here, and so that would be 8, and so on and so forth. So now we'll have to calculate what is postfix. Postfix is what so postfix is basically 4. Initially it was 4, and now this number is 3. So the postfix in this turn is 12. So now 12 will be multiplied by 1. So that's what we'll type here. But now what is postfix now? Postfix now would be 12 cross 2, because now the nums of I is 2. So that's 24. So then 24 will be multiplied by 1. And we have reached the final stop. So if you see, this is the same as what we wanted, which has to be the case because now it's a multiplication of prefix and postfix. So now we can finally return the resultant array, and let's run it. Passes fine.